This video is about the photoelectric effect. We learned in topic 4 that in some situations, light can be considered as a wave. Then, in topic 7 we discussed that light can also be considered as a packet or quantum called a photon. In fact, all electromagnetic radiation can be treated as a wave in some situations, while in other situations, it must be treated as a collection of photons. This concept is called wave-particle duality. The photoelectric effect is an example of a situation when electromagnetic radiation behaves as a particle. Let's see how the photoelectric effect works. When a metal surface is exposed to electromagnetic radiation, photons are incident on the surface. The photons interact with the electrons in the metal. Each photon interacts with a single electron. If the energy of the photon is larger than the work function of the metal, the electron is emitted from the surface. The work function of a metal simply expresses how tightly are the electrons bound to the metal surface. The more tightly the electrons are bound, the larger the work function of the metal is. In turn, a larger work function means that the incident photon must also have a larger amount of energy in order for the electron to be emitted. So when an electron is emitted from the surface, some of the incident photon's energy is used to overcome the work function of the metal. Any additional energy supplied by the photon is converted into the kinetic energy of the electron. An important point that often comes up on IB physics exams is that increasing the intensity of the radiation does not increase the kinetic energy of the emitted electrons. It only increases the number of electrons that are emitted from the surface. The reason is that increasing the intensity of the radiation means increasing the number of incident photons, but not the energy of the photons. The definition of work function also tends to come up on IB physics exams, so here is how you can answer a work function definition question. In addition, there are two formulae that are related to the photoelectric effect and that you can find in the IB physics data booklet. Here are the formulae, and these are the variables that are present in these formulae. You often have to combine these two equations when solving questions in this topic. This completes our discussion of the photoelectric effect. In the next video, we'll learn about matter waves.